This is task 2 for my internship, and the algorithm used for classification using decision tree is, of course, a decision tree classifier. The difficulty marked in the TSF grip task list was intermediate. Let's begin. So first things first, we're going to load the dataset, and we have different important libraries here that we'll be using in our notebook. The standard libraries. The IPython library that I'm using is basically just to use certain GIFs. So just to make it interactive, I'll be displaying certain GIFs so that it's a little bit fun and it's a little bit more relatable to people that are from the non-technical background, as I have said in my previous video. Okay, so this is the data set. We have the features and we have the ID and we have the species. Moving on, this heat map is just for the correlation among the features. So whenever you are making a heat map, you can make heat maps for different reasons. You can use heat maps to find out missing values in your data set. If you're, let's just say that if you're doing a credit risk, prediction and you have a risk flag, you can find out the different features that are required for those two class labels, to be dependent on. And we can also find out multicollinearities, right? So if there is a multicollinearity among features, it means that one or more feature can basically predict the value. Can be is dependent on other features. So multicollinearity is not good for our model, and I'll discuss that in a later video. But let's just stick to the specific task. So these are the columns. You can make it using dot columns, just to get all the columns. And the type is object. Object as in string is just one and the same thing. Here, what I'm doing is I'm getting all the different class labels. This is just to get the different types of species. So what I did was I used the group by functions for the species, and then I just counted all the species. Yeah, I forgot the word. Sorry about that. So these are all the features for predicting the class labels. Of course, these 4 features are important. So we're going to take it and we're going to store it into an X variable. The class label is species, right? So we need to predict this. Again, we're going to split up the data using train test split. Here it is again. I discussed it in the previous video as well. You can either mention the train size or you can mention the test size. It does not matter. The random state is just for a better splitting up of the data. But I would suggest you that you use random state here. So this is what I was talking about when implementing the GIFs. This is why I included the IPython library, and just a little bit of relatable stuff for the people. So this is the classifier here. Again, we're going to fit it, and then we're going to get the predictions. And the accuracy is 0.9, and I would say it's okay. But yeah, I think it is overfitting, and I need to do some tuning. But yeah, let's just get on with the video. The tuning part is later part. So here I was just installing certain libraries, Pydot Plus and the Graphs for visualizing the decision tree and make it more exact. Right, so this is not necessary here. But again, I would suggest you all to you know install this specific version of scikit-learn in order to implement this entire notebook like 0.2, 0.3, right? And you might get an error for the Graphs library because the executables are not by default in the environment variable path. So you might have to explicitly go to the advanced settings and include that path and edit the environment variable. But here you can also do it for locally. So instead of going explicitly to the advanced settings and adding a path, what I did here, just took my working directory here and then just I added the path directly from the notebook. Okay, if it makes sense. And then finally we're going to visualize the decision tree here using pydot plus. So this is the model that we just made, and these are all the features that are required to make it look like this, and these are all the class labels. Okay, and right png is just to save the image, and here is the decision tree. So thank you very much for watching. If you guys have any questions, you can comment down below. I'll be providing the link to this specific code. uh, you know I'll be putting it on the GitHub repository, and I'll share the link in the description below. Thank you and have a nice day.